Hello, this is question 9 from paper 2 from the 2020 Leaving Cert Higher Level Maths exam. If you click on the card up the top right, you'll find the playlist that has all my solutions to the questions in this paper. And below the video in the description, you'll find a link to an image of this question so you can try it in your own time before looking at this solution. This question is all about two ships, which we're going to put as 2 points there, A and B. The first ship, it tells us, is travelling to east to the right here at 15 kilometers every hour, and this second ship is going straight down south at 30 kilometers every hour. Part A of this question is very straightforward. It asks us find the distance between the two ships from here to here after 30 minutes. So this ship is going to be somewhere along here. This ship is going to be somewhere along here. It's going twice the speed, so the distance will be a bit further. And they want us to find that distance, that's all. Okay, so we need to know how far this ship's going to go in half an hour. Well, it goes 15 kilometers every hour, so in half an hour it will have gone 7.5 kilometers. This whole distance here is 90, so that means this distance left over would be 82.5. And this ship down here would have travelled half of 30 kilometers, which is 50. So the distance, we just have a triangle. It's a quite straightforward question. We just have a triangle. 15 kilometers this side, 82.5 that side. So this side here, let's call it S for distance because we're going to use S later anyway. S would be equal to 82.5 squared plus 15 squared and the square root of that. And we just go ahead and put that into a calculator. I'm reading from my notes here. I get 83.85. I believe they wanted 2 decimal places. They did. Okay, so that's the distance between these 2 points. For part B, they want us to find the general formula for this. So after time t, that means after 1 minute, like 0.1 of an hour, or after like 3 hours, they want us to know what distance away they'll be. So instead of a number here, you'd expect to have t's in it. In fact, they give us the answer. It's one of those questions where they say, show us that this is correct. So to get to they also tell us that it's going to be, the time will be between 0 and 6 hours. That's because after 6 hours, this will get to this point here, and it will start turning to a minus number. As it happens, I think that formula should work because we're getting the distance, and distance doesn't care about minus because we squared. Anyway, not important. The ship will never get further than here. So how do we get this? Let's think more about these two numbers we used, because this is how we got the distance. 82.5 and 15. Where did these numbers come from? I'm going to draw this again. Let's see. We had 7.5 there, then 82. This whole length was 90. So this length here, we got that by saying 90 minus what we found here. And what we found here was just a half times 15. So it was a half multiplied by 15. A half came from half an hour. In this new world, we don't know how many hours. It's t hours. We'll just leave t in there. Instead of half an hour, we have t hours. And this number we got here, 15, again, that was just something multiplied by 30. A half multiplied by 30. That half came straight from the time. Or I could change these, I'll change it on the next line. So that means our general formula for the distance when we don't know what t is, will still equal the square root. In this case, we'll write it like this. The square root of this length here. This length is 90 minus 15t squared. And then plus this length here. That's 30t squared. So it's not quite what they gave us. We have to multiply this out. Let's see, where would we get t squares from? This term squared and this term squared will get t squared. So that's 30 squared plus minus 15 squared. And that should come out from my notes and from the question they gave us. 1125 t squared. Then where will we get t from? 90 multiplied by minus 15. And then minus 15 multiplied by 90. That's where we get all our t's from. So we get, there'll be minus, and it will come out as 2,700 t. Remember, do these, don't just write them down from the notes. So go back to 2007 t. And then where do we get all of our numbers from? That'll be just 90 squared. So 90 squared is, we can do that one in our head, 9 squared is 81, and there'll be an extra 2 tens. So we get 8,100. And that is what they gave us. That is still in a square root, or to the power of a half. And that's it, that's that question answered. So let me go ahead and rub this out. You can pause it and look at it as long as you want, but I'll rub it out and we'll do part C. So in part C, they give us a hint to use calculus. That's very nice of them, and to find the closest these ships get away from each other. The closest these ships are together. And we can do that from this formula here. Did they give us any other clues? No, that's all we need. Because this is the distance between the ships. And the closest, that's another way of saying the smallest. The smallest this distance would get. The furthest away they are would be the maximum these get. So we should have been thinking calculus even without their hint. We're thinking the minimum of this. So the minimum, to find the minimum, we just need to differentiate. The derivative of s with respect to t. So we need to differentiate this. It's the chain rule. We need to think of everything in this bracket as something simple. So derivative of it is a half. Whatever's in the bracket, and then we get minus a half here. Let me just write this out. I'm going to use a lot of ink, I think, on this question. And then, because we cheated, because we pretended what's inside here is simple, we have to fix that. We have to use the chain rule and differentiate what's in here now. So the derivative of this would be 2 times this times t, and we're going to multiply it by. So that would 2 times this would be 2,250. T squared becomes t. The derivative of this becomes minus 2,700, and the derivative of this is 0. And then because we're looking for the minimum, we're looking when the derivative is equal 0. So we just need to solve for this. I think it'll be easier for me to write this out again. I'll edit it out because it'll take me ages to write it. Okay, there we go. Really all I changed is I put this on the bottom row. It's to the power of minus a half, so it becomes a half down there. It's easier to see now when something equals 0. Because the only way something can equal 0 is if the top row is equal to 0, or if the bottom row approaches infinity. And the bottom row can't approach infinity because they told us that t is between 0 and 6. So 6, this might get big-ish, but no, it's not going to be too big for us at all. So it can't approach 0, so we can ignore the point of the bottom row. And so it's really just the top row we're interested in. So or another way to think of it is just multiply the bottom row to both sides. Multiply to the left, it disappears. Multiply to the right, it disappears because multiplied by 0. So save me writing this again. I'm just going to rub the bottom row out. And we're left with this equation. This will be a maximum or a minimum at this point. So we'll get t is equal to 2,700 divided by 2,250. Put that into a calculator and we get 1.2. Yes, we do. Okay, and then they ask, we could double check this is a minimum by differentiating a second time, but it's going to become obvious in a moment if we just stick with it. It's the only answer we get, so we might as well stick with it. They want us to find the actual distance, not the time the distance is at, the actual distance. So I'll do that up this part here. Here's the distance. If we know the time, we can find the distance, and we now know the time. So S 1.2 is equal, just put in 1.2 for this. I've already done it out. I get 80.499, I think it was. Nearest one decimal place, which they asked, is 80.5 kilometers. That'd be the answer to the question. How is this obvious that it's a minimum? Well, when time was 0, it was 90 away from each other. So, or when we did part B, was it, or part A, when time was 0.5, it was 80. Let me check my notes here. It's 83.85. So it's definitely not a maximum because we know of two bigger numbers. So that's a minimum. They didn't ask you to prove it was a minimum or anything. that'll be fine. They just ask for the distance, and once you get the correct answer, you're okay there. If you want and you have extra time, get the second derivative, show that it is bigger than 0, we'll show it's a minimum. Okay, that's the last question in this paper. And last question was surprisingly short, I thought, which is nice to see. If you have any follow-up questions from this, from any other question in the paper, write in the comments below. I'll do my best to answer. Until next time, thanks for watching. Have a great day.